Now this question has an equation which is not y in terms of x, but instead x in terms of y, and we call this type of equations implicit differentiation, which can be a mixture of x and y or x in terms of y. So the first thing that we have to understand in implicit differentiation is how it works. The main concept is d by dx of y is dy by dx. So that is the main idea. So we know d by dx of tan ax is sec squared ax into chain rule d by dx of ax. But if it is d by dx of tan ay instead of ax, it would be sec squared ay times d by dx of ay, which is going to be sec squared ay times, now d by dx of ay is a, dy by dx. So this implicit part is going to have a dy by dx with it. That is the main idea. So first of all, let's find the gradient of the curve, because after all, to find the equation of a normal to the curve, this is from C1, we need to know about the gradient of the curve, because if you remember C1 review, equation of a line is if a line passes to the point x1, y1 and it has a gradient of m, then the equation of the line is y minus y1 equals to m x minus x1, regardless of what type of line it is, normal line or parallel line. That's the equation of the line. Now the gradient rule for a normal line is gradient of normal. So gradient of normal line is equals to minus 1 by dy by dx, meaning gradient of the curve at that particular point. So these are the two things that we need to know. So let's start with this. So first of all, we have x equals to 2 tan. Let me call this entire paraphernalia, entire mess of an angle, theta. So 2 tan theta. So if we differentiate both sides, it would be d by dx of x on this side and d by dx of x on the other side. So 2 tan theta y plus pi by 12. So d by dx of x is 1 and d by dx of 2 is 2. Tan theta is sec squared theta times the chain rule, which is d by dx of the angle, which is y plus pi by 12. So this is going to be 1 equals to 2 sec squared y plus pi by 12. Now think of this as a constant, because 12 pi by 12 is a constant. So d by dx of y is dy by dx. So now what we can do is we can send this sec squared to the other side. So this would be 1 divided by 2 sec squared theta equals to dy by dx. Now since we know how to calculate cos squared but not sec squared, so what we do over here is we can write it as half. Now sec squared reciprocal is cos squared. We can write cos squared y plus pi by 12. So we got an expression. Remember, this is not the gradient of the curve. It's the derivative of the curve, an expression for the gradient of the curve. So we have to put the value of y coordinate pi by 4. So let me put it over here. So at y equals to pi by 4, dy by dx equals to half cos squared pi by 4 plus pi by 12, and that turns out to be, so 1 by 4 plus 1 by 12, that is 1 by 3. So pi by 3 is 60 degrees. So this is half cos squared pi by 3. Now cos 60 degree is half. So this is going to be half into half squared. So this would be 1 by 4 into 2, 1 by 8. That is the gradient of the curve. So now gradient of the normal is going to be minus 1 by dy by dx. So gradient of normal equals to minus 1 by 8, which is minus 8. Now we are going to use the equation of the general line y minus y1. This is known as the point slope form of the equation of the line. Y minus y1 equals to mx minus x1. But we need to know the y coordinate, the x coordinate. We know the y coordinate is pi by 4. We need to know the x coordinate. So let's find that out. So at y equals to pi by 4. So let's put it in the equation. So x equals to 2 tan pi by 4 plus pi by 12. So it is 2 tan pi by 3. So tan pi by 3 is tan 60 degree. Tan 60 degree is root 3. So this is 2 tan root 2 root 3. So now equation. So equation of the normal. So y minus y1, which is 2 square root 3, equals to m, which is minus 8, x minus x1, which is, no, this is, let me correct this, y is pi by 4, so this will be y minus pi by 4, and x minus 2 square root of 3. So that's the equation. Now if you want to simplify it, you can, but in this particular question they didn't say that you have to give the answer in a particular format or simplifying, so keep it this way, it's alright. Now this question is a trigonometric solving question, and the logic and the steps are exactly like the ones in C2. So the first thing would be is to simplify this and solve it. And I would recommend don't break it down into sine and cos, just keep it in this format. That will be better and quite simpler. So the first thing you need to remember is the identity. Cot squared theta plus 1 is identical to cosec squared theta. That is the identity we're going to use for the first step. So we can write 2 cosec squared. So 2 cosec squared. So the angle here is 3 theta minus 1 equals to 7 cosec 3 theta minus 5. Let me explain why did I write minus 1. Because if we go to the next step, then we can get cosec squared theta is identical to cosec squared theta minus 1. Our theta is actually 3 theta. That's why I wrote 3 theta. So that is the first step. Now let's simplify this. This is going to be 2 cosec squared 3 theta minus 2. Let's bring these to the other side. Minus 7 cosec 3 theta plus 5 equals to 0. Now we can write 2 cosec squared 3 theta minus 7 cosec 3 theta. 5 minus 2 is 3, so this is plus 3. It's always a good idea to use a substitution. So let cosec 3 theta be a. So we can write 2a squared minus 7a plus 3 equals to 0. If we do middle term break, 2 3 is 6. So 2a squared minus 6a minus a plus 3 equals to 0. If we take 2a common, it would be a minus 3. If we take 1 common, it would be a minus 3 equals to 0. So this is going to be a minus 3 and 2a minus 1 equals to 0. If we solve it, therefore a equals to 3 or a equals to half. Now let's get back to the sum. So if we take for a equals to 3, that means cosec 3 theta is equals to 3. So cosec 3 theta equals to 3. Now we know cosec is the reciprocal of sine. So sine 3 theta equals to 3. Therefore sine 3 theta equals to 1 by 3. Now we have to solve it using the quadrant rule. So first of all, let's draw up the quadrant. So sine 3 theta is positive in the first quadrant and the second quadrant. That is the step 1. You see whether sine 3 theta is positive or negative. This one is positive. 1 by 3 is a positive value. So it's in the first quadrant and second quadrant. Step 2 is to find the basic angle. The basic angle is 3 theta. So sine inverse of 1 by 3. So the angle is going to be always with the x-axis. So sine inverse 1 by 3. And remember, usually in C3, C4, all the angles are in radian mode, but this time it's in degree, it's 180 degree. So let's use the calculator. So this is going to be sine inverse. Sine inverse of 1 by 3 is 19.5 degree. So 19.5 degree. So do not break this 3 theta. The 3 theta actually represents multiple angle. That means from 0 to 360 degree, instead of 2 angles, it is going to have 3 times of that, meaning instead of 1 pair, it's going to have 3 pairs, meaning 6 angles. Let me repeat, this is what it looks visually. This is y equals to cos theta. So visually it looks like this. It has 2 from 0 to 360 degree. But if you write y equals to cos 2 theta, visually it would cut at 4 places because it is repeated over 0 to 360 degree. And if it is y equals to cos 3 theta, it would cut 1 2 3 6 times, 1 2 3 4 5 6 from 0 to 360 degree. Now if you take a look at the question, the range is 0 to 180 degrees. So instead of 6 answers, we're actually going to have half of that, meaning 3 answers. So let's get on with it. So this is going to be 19.5 degree, and this is also going to be 19.5 degrees. So the first quadrant, the angle is going to be the same as the basic angle, so 19.5 degree. And the second quadrant, it is going to be 180 degree minus 19.5 degree, and that turns out to be 160.5 degrees. So 160.5 degree. We need one more. So that means we're going to do one revolution. So we're going to add 360 degree to this. So 3 theta equals to 19.5 degree plus 360 degree for one revolution because it is 3 theta. So this is going to be 360 plus 19.5, and it is 379.5. Let's check with this also whether it goes into the range or not from 1 to 180 degree. So this would be 160.5 plus 360 degree, and that turns out to be 60.5 plus 360, that is 520.5 degree. 520.5 degree. Now let's write down the answers. So theta equals to 19.5 divided by 3. So 19.5 divided by 3, that is 6.5. So 6.5 degree. The next one is 160.5 divided by 3. So 160.5 divided by 3, that is 53.5 degree. 53.5 degree. And the next one is 379.5. 379.5 divided by 3, that is 126.5 degree. So 126.5 degree, that is 520.5 divided by 3, and that is 173.5 degrees. So it indeed is within the range, 173.5 degrees. So that is 1 decimal places. Now remember, there is one more value of a, which is half, but this will not really work because as you can see, if we write for a equals to half, so we can write cosec 3 theta equals to half. So the reciprocal of cosec is sine 3 theta. That makes half as 2, and it is not possible because the maximum value of sine theta can be 1. So this is not possible. So the answer is going to be 6.5 degree, 53.5 degree, 126.5 degree, and 173.5 degree.